Dear ladies and gentlemen, on behalf of my colleague from the Wuhan University and also from the Newcastle University, today I will present some result about the solar radiation pressure model for the BeiDou GEO satellites. As you know, up to now there are 6 GEO satellites has been launched, but unfortunately G2 has been active. Although all of the GEO satellites carry a satellite laser ranging arrows, but only G1 has been tracked by the ILRS. So in the presentation, all of the validation result is only for the G1 satellites. For BeiDou, the second generation BeiDou satellite, whatever the IGSO, MEO, or the GEO, all of them are based on the 2A satellite platform. So for the satellite bus, IGSO and MEO and the GEO all of the same, except the GEO satellites carry a communication antennas. So in this table I list all the crucial geometrical and optical priority for the GEO satellites. For satellites panel in X, Y, and Z, and the solar panels, I get it from the IGSO and the MEO. The communication antennas, this value I guessed value, so it's not quite accurate. The BeiDou GEO satellites use the orbit to normal altitude mode. For I list the orientation, how to calculate its orientation of the satellite reference frame in the space, and also list a redefined DYD model. So for the complete case, I also give the definition in the Yaw theory model for both of them. So there are three essential angles for the explain the quite essential for the solar radiation, which is mu and the beta and the epsilon. I also uploaded in the figures. For the limitation of the BeiDou GEO satellite, except the altitude model, the quite essential is the tracking geometry, because the satellite is almost stick to the ground stations. So there are some options to improve the situation, which we can use the LEO or the MEO onboard data. But however, up to now, there is only one LEO satellite named Fengyun 3 Fengyun 3 have the data, but no onboard MEO data. For the others factors, it really has minimal impact on the POD. So the next, let's go to the solar radiation pressure. Up to now, there are several, but I listed Amplitude 2 on here, which was proposed by 2 Chinese colleges. It definitely need to be improved. As to my validation, I think there are some space to be improved for these 2 models. But for the others, the most widely used is the eco model, although it's originally developed for the Yaw theory model, but for most of the analysis of them guessed. So we use it to determine orbit for the GEO satellite, except that there are adjustable boxing model, because this model has several advantages. The first is that it can adopt the change of the altitude. So that means that it can be used to describe the solar radiation model, even whatever the satellite altitude used. And recently, Oliver proposed a new semi-analytic model for the QZSS, and definitely it can be used for all of the ON orbital normal. Can be used for all of the satellites which use the orbital normal model, such as the GEO. So I list the orbit the orbit from the two analyzed center of gas, the GFZ and the Wuhan University. So for the cross operation, they are pronounced beta related orbit angles orbit errors in the along and the cross directions, and with satellite satellite laser validation SLR validation. So we can also it can also show there are some errors even in the radio directions, because there are there are large bells up to about 40 centimeter, and there are also epsilon angle related errors in the SL residues. So we start from the digestible box model and try to improve the GEO's orbit. And what we did is use the orthogonal model and the satellite the solar panel points to the for this redefined the directions. In this case, we try to mix the normal directions of the solar panel is predicting as predicted. Sorry. And in addition, the optical parameter has been estimated for all of the illustrated surface, and we do two tests without depending on if we consider the contribution from the communication antennas. The first is we not. Definitely we can see the bells is reduced, but the epsilon dependence error is still here. So once we consider the communication antennas, yes, it's good. The bells is almost eliminated, and the epsilon angles dependence errors is also complete relimited. So from what we have obtained from the ABW model, yes, sorry, but for the DVD test, it's not good. That's a reason we still need to be improved. So from the ABW model, we try to determine determine the value of the parameter for the DLR model, that which was developed by Oliver Montenbrook. So because the parameters in the model are high correlated, so and what the period optical and geometry coefficients we use in it is incorrect. So it's hard to, we had to make a lot of tests and iterations to get what we think is the best. So with this, finally we choose 7 parameters and list its values. And with this, we calculate the GEO's orbit. So the satellite laser SLR validation is still good, but there are a noticeable bias, although it's not large up to 14 centimeters, but it is still 8 centimeters. That's we think maybe this more we need to improve the coefficients later. Maybe we can reduce the bells. And also, we use a pure empirical fitting approach to get another pure models. Yes, sorry. For this model, the DVD is not as good. So for the fit empirical fitting approach, we first we do the spectral analysis and found some mean spectras and get the formula for the appearer models, and by fitting the coefficients with the reconstructed acceleration from the BeiDou model. So we show in here we show the variation of all of the coefficients. That means we need to further to use a formula or equations to describe the change of those parameters, and for others it's almost a constant. So finally we got the periodical empirical fitting models. So that's his coefficients. With this model as used as a appearer and also cooperated with the econ model, but in the ON tab, so we can obtain a good SCR validation result. So the belt is about 3 centimeters, and standard deviation can be reached to 12 centimeters. Maybe that's a bit lower than the Oliver's model. However, for those three, what we did from the BeiDou and what did from the what we obtained from the DR model and from ours, so the DVD still is not good. So it's quite strange. However, but if we change the econ to use the original in your stereo, so in this case we can obtain not only a good orbit, not only in SCR validation, but also in DVD. For this, we need to investigate more to answer what the reasons may be related to the bad geometry observations. For general summaries, so we found there are light belts and epsilon angle dependence error in the GEO satellites. So these satellites mainly caused by the unmodeled contribution from the communication antenna, and for whatever the 3 order, it can be obtained almost a similar performance for the GEO satellites. And with the YS DYB form, so his date boundary discontinuity is also good. So that's all. Thanks for all.